Hey, ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 9, Quiz 1. So we're going to go over the things that you need to be aware of for that quiz review. So let's go ahead and let's take a look at the first problem. Now this one is talking about graphing inversely. So when we do that, the first thing we want to do is multiply the 4 and the 5 together. So we're going to get an equation that xy is equal to 4 times 5, which is 20. So always in the center we have 0, and that's going to be undefined. So then I get to pick values for x, and I always like to pick values that divide out x evenly. So I'm going to pick 2, 4, 5, and 10, because that's going to make sure that 20 is divided into non-decimals, because frankly, I don't like graphing decimals. So then we're going to do the same, but with negatives over on this side. Okay, so now we need to figure out what our y values are going to be. So I'm going to do 20 divided by 2, which is 10, divided by 4, which is 5, divided by 5, which is 4, divided by 10, which is 2. And then I'm going to go ahead and mirror that onto the negative side. So then I'm going to have this go by 2. So I have 2, 4, 6, 8, and 10. So then if I'm going to go ahead and graph this, I'm going over 2 up 2, 4, 6, 8, 10. Now remember, if you ever change your scale, it's really, really important that you tell me how you're changing it. Then we're going over 4 up 2, 4, and then 5 is going to be halfway between 4 and 6. But halfway between 4 and 6 is going to be 4. And then we're going to go over 10 and up 2. So we're going to go ahead and connect those dots. Now this is going to be the first half. And then we're also going to have -2, -4, -6, -8. And those are terribly written, but hopefully you could hear me enough. So then we're going left 2, down 2, 4, 6, 8, and 10. So that's going to be right here. Over 4, down 5, we're going to go halfway between 4 and 5. Then we're going over 5, up 4. And finally over 10 up 2, or down 2. Sorry, I should be saying that because it's negative. I should be saying down. So we're going to go ahead and graph that. So this is your graph for number 1. Now keep in mind, you never want to be crossing the x or the y axis. It should be kind of locked in to that first and third quadrant. So let's take a look at number 2. It wants us to graph the inverse variation equation. So what we're going to do when x or y is equal to 4 and x is equal to 9. So our equation xy is going to be equal to 36 when we do 9 times 4. So in the center, I'm going to have 0, and then I'm going to have undefined. Again, I want to pick values of x that work well for 36. And if you pick decimals, that's okay, as long as you're comfortable graphing them. So we're going to have 3, 4, 6, and 9. And over here, -3, -4, -6, and -9. So then 36 divided by 3 is 12, divided by 4 is 9, divided by 6 is 6, divided by 9 is 4. And we're going to have the same thing over here, but in the negative. Okay, so now we're going to go ahead and graph it. And so I can maintain consistently, I'm going to change the scale of my graph, again, which you should always note on there. And I'm going to do 3, 6, 9, 12, 3, 6, 9, 12. So what we're going to do is we're going to go over 3, up 12, and plot that point. Over 4 is going to be 2/3 of the way between 3 and 6. I'm going to go over 1/3. And I'm going to go up 4, I went over 4 and up 9, so that's going to be here. Then I'm going over 6, up 6, which is here. Over 9, up 4, which again is going to be 1/3 of the way to 6. So now I can go ahead and plot these. Now I'm going to do the same on the other side, except it's going to be negative. -3, -6, and so on. So I'm going to go left 3, down 12. 3, 6, 9, 12. Which is here. I'm going to go, oops, that's a terrible point. That should be right there. Then I'm going to go over 4, which is 1/3 of the way. And then I'm going to go down 3, 6, 9, which is here. Then I'm going to go over 6, so 3, 6, and down 6, 3, 6, which is here. And then over 9 and up 4, which is going to be 1/3 after that. So then I'm going to go ahead and connect my points. And remember, not crossing that x and that y axis. So let's go take a look at some product rule problems. So taking a look at number 3, it says y varies inversely, if I can spell, as x when y equals 6 and x is equal to 9. So now we're going to have 6 times 9, and we need to find x when y is equal to 18. Well, 6 times 9 is going to give me 36, and that's going to be equal to 18x. So now to solve for x, I'm going to go ahead and divide both sides by 18, and I end up getting that x is equal to 2. So that's my final answer for number 3. Now, let's take a look at number 4. So if y is 20 and x is 5, I'm going to multiply those two together. We need to find x when y is 25. So 20 times 5 is going to give me 100, and that's going to be set equal to 25x. So I'm going to go ahead and divide both sides by 25, and I end up getting that x is equal to 4 as my final answer for number 4. Setting up number 5. I have y is equal to 6 when x is equal to 12, so I'm going to have 6 times 12, and we want to find x when y is equal to 4. Remember, this is just using that product rule. So 6 times 12 is going to give me 72, and that's going to be equal to 4x. 4x is the same as x times 4. So then we're going to go ahead and divide both sides by 4. 72 divided by 4 is going to give me 18. So here I get that x is equal to 18. Now, we want to find y varies inversely as x, so we know that y is 4 when x is 3, so we're going to multiply those two together, and we want to find x when y is 6. Well, 4 times 3 is 12. 6 times x is 6x. Divide both sides by 6, and we end up getting that x is equal to 2. Okay? Now let's do a word problem version of these, which really aren't that much different, so don't freak out because it's a word problem, because I know you guys can do it. All right, so when two people are balanced on a seesaw, their distance from the center of the seesaw are inversely proportional to their weights. So a 118-pound person sits 1.8 meters away. So I'm just going to write that in a parenthesis. 108-pound person, 1.8 feet away. That's going to be my x to my y. Now we know these are varying inversely. Keep that in mind. How far should a 120-pound person sit from the center to balance the seesaw? So these two are also going to be inversely related. So what I'm going to do is I'm going to take my x times my y on this side and set it equal to my x times my y of the other one. Well, 118 times 1.8 is going to give me 212.4, and that's going to be equal to 120y. So now I need to solve that for y. So I'm going to go ahead and divide both sides by 120. Now, when I do that, 212.4 divided by 120, I get 1.77 meters. As always, guys, check your rounding. If the third number is 5 or greater, you need to be rounding up, so be keeping that in mind. All right, let's take a look at number 8. So simplifying this down, the first thing I like to do is just take a look at the big numbers. So I have 12 divided by 2. Well, I can do that. 12 divided by 2 is simply 6. Here I have x to the 4th divided by x squared. So now I'm going to ask myself where my larger amount of x's are. And they're on the top. So when I subtract them and get x to the 2nd, my x to the 2nd needs to be on top. Here I have y to the 9th divided by y to the 4th. I'm going to subtract those exponents. Okay, so then I get y to the 5th. I notice that the larger amount of y's is on the top, so that means my y to the 5th is also going to go on the top. Now, let's take a look at number 9. So for number 9, first of all, I have 5 over 15. So I need to think about what divides 5 and 15 so I can reduce that fraction. Well, they're both divisible by 5, so I'm going to write that as 1/3. And then I have x to the 6th, x to the 3rd. Your larger amount of x's are on the bottom, so when you subtract those, you get x to the 3rd. And I want to put x to the 3rd because the larger amount of x's is on the bottom. Then here I have y to the 6th over y to the 4th. Well, when I subtract those, I get y squared. Now, where are my larger amount of y's? Well, they're on the top, so I need to write y squared on the top. So then I can write it as y squared 3x cubed. Now, both of these answers are equally correct, okay? You don't need to write that one there unless you want to. Then have at it. So I would accept both of those. So now we're just going to review factoring. So if you recall, I showed you a trick way of factoring, and if I didn't, we'll review it here. So what we want to do is we're going to take 1 times 12. Well, 1 times 12 multiplies to 12, and it's going to add to 7. So what multiplies to 12 and adds to 7? Well, that's going to be 3 and 4. Remember, if the term in front of the squared term is a 1, which it is here, or there's no number written, remember that means a 1 as well, then we can immediately write it into factored form. So these are your factors for number 10. Now, let's take a look at number 11. So we have a 1 out in front here, so we're going to do 1 times negative 32. That's going to put a negative 32 here and a 4 here. So we're multiplying to a negative 32 and adding to a positive 4. So we know we're going to have positive and negative factors. So when we do that, I want to make the larger number positive because my sum is positive. So I'm going to have 8 and negative 4. Again, because this is a 1 in front of the squared term, I can go and immediately put that factored form. Now, the way we learned towards the beginning of this year will always work. This is a shortcut which you may want to use moving forward because we're going to be doing factoring along with some other things. So that concludes your review video. Please let me know if you have any further questions. Thanks for listening.